in general, how do we define the expected value of a discrete random variable? If we know its probability distribution, then if you imagine what happens when you draw over and over and over again, the frequency with which I get a particular value is going to approach, in high probability, the probability of getting that value. So in this case, this is supposed to be the probability distribution of the sum of two draws from that box of tickets that we were just looking at. So let's verify that this is right. So I'm going to draw twice from that box of tickets and calculate the sum of the two draws. Then I'm going to draw twice from that box of ticket and count the sum of the two calculate the sum of the two draws. I can do that over and over again. So I have a new experiment. The experiment is not drawing a sample of size 1. It's drawing a sample of size 2. But I'm going to repeat that experiment many, many, many times and look at the values that I get. And I'm interested in what's the average outcome for that experiment, the long-run average outcome. So what's the probability that the sum of two draws is equal to 0? Well, how does the sum of two draws end up being 0? I've got to get a 0 on the first draw and a 0 on the second draw. The two draws are independent. I'm drawing with replacement. So the chance I get a 0 on the first draw is a quarter. The chance I get a 0 on the second draw, given that I got a 0 on the first draw, is also a quarter because they're independent. So the probability that I get a 0 on both is a quarter times a quarter, or 1/16. Right? Okay. What's the chance that I get a 1 as the sum of the draws? What's the chance the sum of the two draws is 1? Well, I can either get a 0 and a 1 or a 1 and a 0. Right? I have two possibilities. Those are disjoint, right? If I get a 0 on the first draw and a 1 on the second, I didn't get a 1 on the first draw and a 0 on the second. Did I say that right? Okay, so I can find the probability that the sum is 1 by finding the probabilities of those two possibilities and adding them together because they're disjoint and exhaustive. They're a partition of the event that I get a 1 as the sum of the two draws. So what's the chance I get a 1 and then a 0? Well, there's a 50% chance I get a 1 because there's two 1s in the box. And then given that I get a 1, there's a 25% chance that I get a 0 on the second draw because the draws are independent and there's 25% zeros in the box. So I get 0.5 times a quarter is an eighth, right? And then the other way around, what's the chance I first get a 0 and then get a 1? I've got a quarter times a half, which is another eighth. So I have an eighth plus an eighth is a quarter is the probability that the sum is equal to 1. Okay? What are the ways of getting 2? You can get a 1 and a 1, a 0 and a 2, or a 2 and a 0. Right? 1 and 1 is a half times a half is a quarter. 0 and 2 is a quarter times a quarter is a 16th. 2 and 0 is a quarter times a quarter is a 16th. So I get 2 16ths, which is an eighth, plus a quarter is 3/8. Did I do that right? No, I did leave something out? Oh, I'm sorry, there's no 2 in the box. Okay, that would explain it. Yeah, I was thinking that there was a 2 in the box. Keep your eyes on the box. Okay, so yeah, so there's only, you can, to get 2, you have to get a 1 and a 1. That's the only way you can do it. And the chance you get a 1 and a 1 is a half times a half is a quarter. All right, okay. So we can work this out and find the whole probability distribution for the sum of two draws from this box. These are the possible values. Those are the only sums you can get. And these are the probabilities of these values. Well, if we repeated this experiment of drawing twice from the box over and over and over again, each time adding the results, we would get 8 about a 16th of the time. We would get 5 about a quarter of the time, etc. The expected value of this is going to be 0 times a 16th, plus 1 times a quarter, plus 2 times a quarter, plus 4 times an eighth, 5 times a quarter, 8 times a 16th, right? Because we'll see each of these values about that often. Okay, so it turns out that the expected value is 3, which is twice what the expected value was for one draw from the box. Okay, that turns out to be true in great generality. The expected value of n draw, the sum of n draws from a box is equal to n times the expected value of one draw from the box. The expected value of one draw from the box is the average of the numbers on the tickets, where you take into account repeats. So in this case, it's the average of 0, 1, 1, and 4. Right? That turned out to be 1.5. The average of 37 draws from this box, the expected value of the sum of 37 draws from this box would be 37 times 1.5. Okay? The experiment is pull 37 tickets out of the box with replacement, add them. Do it again. Pull 37 tickets out of the box with replacement, add them. You get number each time. Imagine doing that over and over and over again, an enormous number of times. Each experiment consists of pulling 37 tickets out of the box with replacement. What would the average of that list be? Well, with increasingly high probability, the average of that list would be increasingly close to 37 times 1.5. 37 times 1.5 is the expected value.